Hi everyone, welcome to Goal 2, and we have requirement 3 and 4. I would set requirement 3, it says protect stored account data. Requirement 4, protect cardholder data with strong encryption. That is data in transit, and we know what that means. But let's break down requirement 2 better. Requirement 3 rather. I don't know why I put two. It should be requirement 3 because I already touched requirement 1 and 2. Yeah, so requirement 3. So protecting account data, or is the goal. First, protecting account data is a key to maintaining customer trust. At the end of the day, your most valuable asset or valuable, yes, customer trust is the most valuable, all right? Because if I'm trusting Bank of America or any other bank with my information, I expected them to protect it. If not, if they receive a breach or if they get hacked, of course, with a competition, I want to switch to maybe Chase or any other bank. And that's why we talk about maintaining customer trust. This involves the encryption of cardholder data, both at rest and also during transmission. That's data in transit. And I know we've briefly touched based on the different type of encryption, what to use, even the encryption algorithm, by using strong encryption protocols, we ensure that even if a data is intercepted, it cannot be read or misused. It cannot be read or misused, right? This eventually tells us that, as always, make the claim that the data is useless. Not that the data on its own is useless, but if an unauthorized person get access to that data, they won't be able to access the data. For example, we talk when processing payment. For example, the sensitive card data holder should be encrypted using industry standard encryption algorithm. Algorithm that's AES Advanced Encryption Standard 256. As a matter of fact, I don't know if I mentioned already. I'll definitely go through the FIPS 142, 140-2, which talk about the different encryption. That's something that I know I'm going to do it. That way I can come up with, just I'll create a video on that, but you can also visit the FIPS document, go to the next page or website. You should be able to, check the document, ensuring that data cannot be read by an unauthorized party. And this simply tells us if it is sensitive data, data protection, and we're talking about debit or credit card, and the fact that it's been encrypted, right? But the main goal of this requirement or the goal is to safeguard sensitive data such as cardholder data from being accessed by an unauthorized party or parties. And now, as I said, don't stress about the cardholder data. We have slide that will go over it. Okay. This is achieved through the encryption techniques, both when the data is stored at rest or when the data is being transmitted over the network. That's data in transit. And this gives us a good pictorial overview of what we've discussed. If this data is at rest, store in your database that is being located in your internal. Remember, internal network, we talk of the ports where you have the POPs network zones, separated from other or segmented from other network. And then, but in transit, you also want to make sure you have, it's being transmitted securely over HTTP as a secure protocol or an port 443 or an encrypted using either TLS encryptions or SSL, right? So encryption of cardholder data both at rest and during transmission. Encryption, first again, just a recap, is a process of converting data into a code to prevent unauthorized access. They ensure that even if someone intercepts the data, they won't be able to understand it without the decryption key. Think of encryption like you live in your house, you lock your door, you go. If someone does not have the right key, they won't be able to log in or to get into your house. If you are going out, your husband needs to come in with the same key, or if you're going with ADT or any other services or company, then you can also have a code that you will use to be able to access your house. So if someone put in the wrong code, of course, they won't be able to access. So that's exactly what encryption does, right? So if you look at rest, we talk about data that is stored on the server, database, or any other storage medium. If a hacker were to gain unauthorized access to the storage device, they will only encounter unreadable encrypted data. Do you now see the reason when I said that encryption makes render the data useless for if an unauthorized personnel get access or authorized user get access to that data, pretty much a hacker, right? And that's why even if they manage to bypass all the network security that we put in place, bypass it, get into the database, if this database is also encrypted, they won't be able to read from it. So it still render the data useless, but it doesn't mean that the data is useless. Unfortunately, it was the point of you getting something and you're not able to read from it. Doesn't make any sense. So they've wasted their time, right, trying to get into an organization system. And this eventually explain all what we'll be discussing. You see, you will just imagine say that, hey, meet me at this place, or I'll see, or better still, I will be uploading video starting tomorrow, and that data is being scrambled, is being encrypted to generate, this hypertext as the encryption text. So even if you get that message, it's useless because you cannot read. What is it? Myself, I don't know what that thing is, unless maybe someone can help me with that. Okay, and then talking during transmission, this refers to data being transferred across networks between website, payment gateway. Even if someone were to intercept the data while being transmitted, encryption ensures that the data remains unreadable. And this is a perfect example from the client. Everything goes over the network. If you go to our website, you will check. You can even see like the person that supplies that provide our certificate, check when our certificate is valid, if at all is valid, when we need to renew it. You can get all of that information, on our website. And whatever things that happen on our website, it is also secure and encrypted. Okay. Yeah, so let's see some real world examples. Say, for example, imagine an online shopping website where a customer makes a payment using their credit card. Let's see how it's been protected. The very first one, encryption at rest. The website store the customer credit. Now, I hope you guys have seen now how PCI DSS is coming to life. That website store customer credit card information in the database. To protect this sensitive information, the website uses Advanced Encryption Standard, AES 256, to encrypt the cardholder data. AES is a robust encryption standard, ensuring that even if the database is breached, the stolen data remains unreadable to the attackers. You understand? And that reminds me, again, we have somebody that's hosting our platform. We have our databases there, right? Encryption in transit. When the customer enters their credit card, because this is what we are talking about, encryption at rest, the first one, it stores that customer data. Some of you, when you go to some of this site, you already store your information, right? Remember, like, do you want to store your card? Yes, boom, you store it. That way they can do auto payments. So this is exactly what we're saying. When you store those cards, it has to be protected, because if not, if their system get hacked, their database get hacked, yeah, information will be exposed. Right? And that's why they also have to make sure that if they are storing card data holder, then they have to protect it. They have to encrypt it. But that's not only it. What happened to the transmission itself? What happened to the fact that that data will have to transmit before even getting to their database? What happened to the fact that they have to go through different routes, different like routers, switches, web server, application server? Just imagine all the different things that we've covered. How is it also being protected? And that we start talking about the transmission communication. And that's why I said you also need to make sure you understand protocol and port, how communications work, guys, right? Encryption in transit. When the customer enters their credit card details and submit the payment, the information is transmitted over the internet. This transmission occurs using HTTPS, that's the secure version of Hypertext Transfer Protocol Secure, which encrypts the data in transit using either SSL or TLS encryption protocols. So you want to check the most current version. What version are we supposed to go with, SSL or TLS? This makes it virtually impossible for attackers to eavesdrop or to intercept sensitive information while it's being transferred, right? So encryption at rest database, we see that. Imagine a locked vault where sensitive data like credit card numbers is stored. Even if someone breaks into the vault, they cannot read the content without a key. This is akin to AES 256 encryption, which secure database inside the vault, inside the storage or storage medium. That makes sense. Why in transmission, imagine imagine a secure delivering service where sensitive items are shipped with a sealed tamper-proof box. Even if someone tries to intercept the shipment, they cannot open the box without a proper authorization. This is like the encrypted transmission payment data using HTTPS. And if you see, this is a database. Do you see once you have this? You see, if you don't have this key, this thing is locked. It is locked, so you cannot access it, right? And then if we go to transmission, do you see? Transmission, that is what we talk. If they are, we mentioned about, they have the tamper-proof box, even this thing, even you try, if you don't have the proper authorization, still you won't be able to access it. And likewise, in the computer world, this is exactly how it happens, okay? All right. Then we'll go now. The next goal is goal 3, and I'm gonna pause it. Goal 3, where we'll take requirement 5 and 6. It says maintain a vulnerability management program. So we'll cover that one. The next video, I will definitely see you.